All right, well, I guess we'll go ahead and get started. And as people come in, that'd be great for them to join. And we'll also have this presentation recorded, so we'll be able to send out copies as well to everyone that registered. So again, thank you for everyone for attending the webinar. For basically, you get a chance to ask some PureAir experts in regards to this chemisorbent medias and different polishing medias. So do a little different on this webinar where we invite questions during this presentation. So first, I'm just going to discuss a little bit about PureAir filtration and chemisorbent medias, and then we'll open it up. We had some people submitted some questions, which was great. We really appreciate those. We're going to post those, and then we'll also take live questions as well. So as we get started, again, let me just introduce myself. My name is Anthony Yamini. I am the Vice President of Sales here at Business Development. So I've been at PureAir now, going on 19 years. So I've been in this industry for over 24 years. So I've had a chance to see quite a few different systems and applications and solutions. So we're looking very much forward to speaking today in this presentation. So with that, we'll get started. So just kind of a brief agenda for this talk. So introduce PureAir filtration a little, real briefly here. Then we'll go into the chemisorbent media overview, talk a little bit about gas phase filtration. For those that are familiar with with our webinar series, some of this information you may have heard before, but it's always good to have like a refresher. And then from there, we'll get into answering some questions that were presented to us over the course of this past few weeks or so. And then we'll also be able to answer some live questions. So looking forward to it. So again, PureAir filtration, our manufacturing facility here is in Atlanta, Georgia. We are woman-owned since 2023, and we were founded about 21 years ago now. So over 60 employees worldwide, and we actually sell to over 60 countries around the world as well. We are an ISO 9001 certified company, and we'll say we are a single source manufacturer for gas phase filtration media, systems, and also monitoring. And one thing I did not mention having this slide, we also have an ISO certified laboratory as well. So we can do a lot of media testing and also some research and development as well. So very exciting. So the chemisorbent media, this is going to be the focus today. Well, the majority of our questions will be focused around the media itself. So with our medias, the majority of our medias are manufactured in-house. So we are targeting removal of different gases in the industrial, municipal, and also commercial spaces. We can incorporate the media itself in many different vessels or some type of container or vessel to hold the media. Because in essence, the media is the magic behind removing the gases in different industries. So it's really important to ensure that the housing is designed properly to ensure the proper effectiveness of the media itself. And also this media can be used in other existing scrubbers that are out there, systems that may have a different type of adsorbent media itself. Some of the most common gases targeted, as you see, and really in no particular order. If you have ammonia, hydrogen sulfide, different sulfur dioxide, NOx, as well as chlorine, formaldehyde. One gas not mentioned, or gases, family of gases, are VOCs, which are common, but it's not mentioned here, but we'll remove those as well. All right, so the chemisorbent media types. So really going to talk about just kind of the families of the chemisorbents a little bit, or different categories. So starting with the impregnated activated alumina. So alumina is a aluminum oxide, so it's a white pellet. And in essence, that substrate can be impregnated typically with a potassium permanganate, which gives it that nice, bright, rich color. And it can be impregnated with different concentrations of permanganate itself as well. So whether it's 4%, 8%, 12%, or different, maybe it's sodium permanganate. It really just depends on the application and what we're working, what gases we're trying to remove. You can also just use alumina as well as a great desiccant for different applications if needed, and also for siloxane removal. Activated carbon medias, those medias have been used for decades for VOC removal and different gas removal. And the very, say we say plain carbons, for example, either whether it's coconut shell based or a coal base that's extruded into a pellet, phenomenal for moving different VOCs and gases. Now, what's important with activated carbons is that those medias in essence can be impregnated or combined with a different catalyst so it can target specific gases. So for an example, we would take, if you had your extruded coal-based carbon and you impregnate that with some type of an acid, now it's great for removing ammonia, as ammonia is a base. Same with removing acid gases, you would impregnate it with some type of base to remove those acid gases. Now, some of the other more engineered carbons where you take the actual base carbon itself and then combine that with the catalyst and then you extrude it. So it's not an impregnated media. So it's more of a catalytic carbon at that point where it really targets a specific gas. So those are very important. Now with the blended medias, in essence, we're taking the best of both worlds. So now you're taking that impregnated activated alumina media, which is a great oxidizer for different gases, combining that with the activated carbon media, whether it's plain carbon or one of the impregnated or engineered carbons. So now you have just a great polishing media that's going to target a whole family of gases, and that we'll talk about in the next slide. The last two medias, we have one for chlorine adsorbent media, it's our safety sorb for removing more toxic gas. So that media is targeting, say, chlorine or other types of halides just for emergency purposes. And then we also use some medias that are clay mineral based, just for different applications. So some applications require medias to remove very high levels of a particular gas. In those cases, the mineral-based, clay-based media is a little more effective. Okay, so as I mentioned in the previous slide, just some of the different families of the gases, for example, impregnated activated alumina medias. As you see, that is a great oxidizer. So it's going to remove a whole host of different gases from the airstream. So it's great for that. Different concentration levels will increase the capacity of that particular gas or increase the capacity of the media for that gas. Then you have the activated carbons, as I mentioned, where ACX and ACC, being the plain carbons, are great for moving different gases and very common VOCs as well. Now, the remaining medias under the activated carbons, say ammonia sorb, NOx sorb, sulfosorb 2, those medias are actually impregnated with a different catalyst to target particular gases. And for the sulfosorb XL, FeXL, those are more catalytic carbons. So now they're going to target H2S. They will remove some VOCs because the substrate of that media is carbon. So it will have some VOC capacity, but since it's targeted or designed for a particular gas, we really don't highlight that removal. So it's more so just for the H2S itself. And then as you see for the blended medias, when you're blending, for example, for the CP family of blends, that is a plain carbon ACX or ACC blended with one of the impregnated alumina medias. So now you have this broad range of different gases that can be removed from that media. So in essence, that's why we would typically use these medias for polishing purposes. As just to give a quick example, on the municipal industry, where H2S may be the target gas, for application, but from our experience, there's always other gases that are present in that airstream, just from the nature of the process. So in those cases, we would provide a media for H2S, but also one of these blended medias to make sure we remove everything else that would have an odor, because a lot of these odors and gases have very low odor thresholds. So you want to make sure you take out all the gases. So in essence, you can, to protect, whether it's in the municipal industry, from offensive odors getting out to the atmosphere surrounding neighborhoods, or those gases in, or say, oil and gas or industrial applications that are also very corrosive. So just a really different blends for different applications. For example, PP blend, for example, that's great for the pulp and paper industry, as well as even oil and gas, because it's a blend of our sulfur-absorbed 2, which is going to remove different acid gases, and also 8% concentration permanganate for to remove all the other gas as well. So you blend those two together, you're getting a great overall media, especially for the gases that are present in those industries. And we also have this, the chlorine absorbent media, our safety zorb. It's a rule for chlorine and also other halides and fluorine, but it's also great for removing bromine. So it depends on the application. And also in the clay and mineral-based medias, different gases that those remove as well. Okay, in this slide, I want to talk a little bit about gas phase technology and kind of how it works. And this is a very important slide for our systems, especially how PureAir filtration designs a system. So let's turn on my pointer, turn off. Okay, so this illustration here just represents a media bed, whether it's whatever type of system or vessel that's housing the media. So you have contaminated air that's coming into the media bed itself, whatever that air contains: hydrogen sulfide, sulfur dioxide, NOx, SOx, VOCs. So you have coming into the system. This is called the active transfer zone, or the working zone. This little thin band is what is removing the different gas from the airstream. So if you have the contaminated air coming in, this media is already spent, and this active transfer zone is moving along the media bed until the entire bed is consumed. So you still have this working zone here, unused media, and it's going to move until it consumes all the media. And that allows, and that's at that time is when it's time to change out the media. This is very important for gas phase filtration systems, because there's ways to monitor this active transfer zone, which is very important. So that way, now from there, you can predict or calculate when it's time to change out the media. And there are a few devices that we have that we can do that. We can monitor that manually, or most importantly, electronically, to alert end users when it's time to change out that media. So that way, you're not changing out the media too late, or you have the gas or breaking through, or you're not changing out too soon, spending unnecessary money. So very, very important kind of moving forward. And then also for gas phase, two different types of when the technology where you have adsorption, where it's more of a physical process, where, for example, activated carbon and plain activated carbons, where they hold on, they're very porous, so they hold on to the gaseous molecules almost like a sponge. So they come in, they're held in place, so it prevents it from going out to atmosphere. Now with that, the physical process, it can be reversed, whether it's with water, similar to a sponge. You squeeze a sponge, the water comes out. So activated carbon is very similar, where some type of process, whether it's through water or heating, you can actually remove some of the contaminants that were held in place. Or in some cases, if a larger molecule of a gas comes in, it can dislodge it, and you have that off gas, is what they call it. Now, chemical absorption or chemisorption is still a similar process, where the media itself is very porous, so it captures those gaseous molecules. But what happens now, that media is impregnated with some type of a catalyst. So that catalyst, the media, and the gas all react together and then turns that entire media pellet into just a non-toxic solid that can be disposed of. Of course, you have to follow any regulations when disposing of it, because in most cases that media is non-hazardous, but you still have to check with local code before doing any disposal. Now, one of the benefits of the chemisorption as well, especially when we're thinking about the purple pellets, is that that media will change color, as the catalyst is being consumed. So that nice rich purple pellet will start off very purple, bright purple, then it'll turn kind of brown, then it'll go to white when it's spent. So that's a good indication when it's time to change out that media as well. Kind of one of the benefits of that. All right, so that was just a kind of a brief overview of the the chemical absorbent that we provide, engineered absorbents. So now we're going to go into some questions that we had submitted, that we want to just kind of go through, and definitely appreciate everyone's questions. They sent in, they took time to send in. So, excuse me, thank you very much. So the first question was from Miriam. She sent in, and she said, I am looking for absorbents for trace gases. So in those cases, actually, I'm going to fast forward to a different slide here, just to kind of point out some of the different medias that we have. So if we were looking at trace gases, and we don't really have the exact gas that you want to remove, just more, it could be a family of gases, but they're very low level. In those cases, as was shown in the previous slide, we would go with one of the blends for the media, because that has nice broad range. So I think I'll go back to that one. So I would go with one of the blended medias, because that's going to give us just a nice broad range of different gases to remove. Whether it's, and we'll probably start with, our first initial thought would be with the CPS 12 blend. That'll be the plain carbon blended with a 12% permanganate media. That's going to give us the highest capacity for that particular blend for removing those different gases. So I think that would be a great start, for that. Of course, not knowing the industry for that, if it was, say, pulp and paper, I may go with the PP blend, but still would provide a blended media. So thank you for that question. Okay, the next question was from Muhammad Zafar. And he asked, would you recommend replacing a competitor blend media with an equivalent solution for OG application? I'm assuming that means oil and gas application, with a more specific removable media and not a blend, and why? So depending on, if we know more about the application and what gases are present, we may recommend a different media, say, targeted for that gas. And, so that's going to be the most effective for that. I could say the most effective use of time and space for that particular system. Now, I will say, for the oil and gas applications in industry, our experience is when we would use the blended media called the PP blend. So it's actually a blend of the activated carbon that's impregnated to, it's impregnated to remove acid gases, and blend that with the permanganate media. So it's going to give a nice broad spectrum of gas removal tailored to that industry. So really would start there, and also understanding what the competitor blend they provided. Here at PureAir, we have a lot of experience with medias and different systems, so we may not necessarily follow what a competitor is providing. We want to ensure we're providing exactly what the customer needs. It's going to be most effective and give them a long-lasting system. So it really would be, in those particular applications, we would love to have, more information, so that way we can provide with the best solution. All right. All right, so next question was, how long should my media last? Well, typically with our systems, we would design them to last at least 1 year, but that's going to depend on a multitude of different factors. So whether it's the airflow through the system, as well as the concentration of that particular gas, and then from there it can be determined how long that media would last. Now, if there's a system that's already existing, say it was someone else's system that's already existing there, so the amount of media to be provided is fixed, we can do that calculation if we have an idea of what gases are present uh, and the concentration levels. That's most important for us to determine that. So hopefully we'd be able to ascertain that information to determine media life. Okay, next question. It says a system was installed at our plant a few years ago, and the smell seems to have gotten worse despite replacing the carbon inside. We are hoping for an easy fix. Do you know what the issue could be? Well, there could be a few different reasons for that. Really, just it would depend on the design of the system, because you want to ensure, whether it's a horizontal flow system versus vertical flow. Horizontal flow systems, you want to ensure that there's no bypass or any ways for the media, or the gas, the odorous air or gaseous air to circumvent the media itself, because you want that gas to go through the media to ensure that we're getting clean air coming out. So it's kind of we really need to look at the application to really give the best answer, but that would be the first uh, start to determining what the issues would be, and also the type of media itself. Is it just some plain carbon, and what gases are you trying to remove? Whether it's is it H2S or is it VOCs, mercaptans, reduced sulfur compounds? You may be using the wrong type of media. So just because you changed out a certain media, that could be may not be the right media for the project. So, all right. So next question is from Kevin Lee. He says, "How come most well-known media suppliers are from the North America, U.S. or Canada? There are quite a few in Europe. Canfill only make for themselves in Freudenberg." No, that's a great question. I'm not sure how to answer that one. I would say I know activated carbons have been used for decades, as I mentioned previously, for gas removal. But no, a lot of the more of the chemisorbants, especially the purple medias, were founded here in the U.S. Over 40 years ago or so. So maybe with more of that media, the engineered, chemisorbant purple media being designed here, maybe it's just maybe fueled a few different companies to do that, but I'm not 100% sure why other companies haven't done more, especially in other areas. But I know there are quite a few here in North America. So, and also Kevin Lee, I want to mention we received your other email as well, questions. We're going to respond to that here in a separate email. Send that to you, and then we'll also send the answer out to the group as well later, because it was a phenomenal question. We want to make sure we give it the proper attention in response for that. So again, thank you very much for that. All right, let's get some more questions here. All right, so it said we've been using carbon for years for H2S, and it seems to work fine. Why would I want to switch to your media? Well, I would say if you're having no issues, with the system, and just remove it H2S fine, and you're getting great media life and no complaints from the neighbors, I would say do what's best. I would say do what's best for your application and what works best for your budget as well. But in most cases, from our experience, you know, even though it may be great for removing H2S, usually there's always some other odors that are present. So we would just like to take a look at the overall application to see where we could be a benefit. And one of the benefits we have, at PureAir Filtration has been able, we have a world-class ISO certified laboratory where we can actually test medias and do some R&D as well. So it would be just a one great benefit to working with PureAir. With our technology and systems, we have a lot of experience, a lot of knowledge at the company that could be usually can be a great beneficial partner for most consultants and then users. Okay, all right. So do you offer long-lasting media for ACES removal for digester gas? Inlet is 150 to 250 ppm, outlet less than 1 to 40 ppm. We do. We have a media for those applications. It's one of the mineral-based medias. It's called our Sulfazorb FE. And let me just, so it is a clay-based media that is phenomenal for removing high levels of H2S. Up to 3,000-4,000 ppm. So we can definitely provide a system and give you a nice, depending on as far as long lasting, when you get into very high levels, again, we will, depending on your space, we try to design systems that last at least 1 year. So depending on how much space you need, that's just a matter of airflow and contaminant level, and we know that, then we can design the system. All right, next question. Our plant deals mainly with hydrogen sulfide gas, and our current filter media does a good job removing the smell. The problem is we have to replace it every 6 months or so. We thought the maintenance would be easier, maybe at least a year. What can be done? So in those cases, in that particular application, I would want to know what type of media is being used. And there are also different capacities, for the H2S removal media. So depending on what types being used, we maybe go with the higher capacity H2S media that will last a little longer. And also take a look at the overall system. Maybe we can install some type of a filter in the beginning of the unit if it's not there, to ensure that we're getting nice dry air into the unit, so it's not impeding the effectiveness of the media itself. As I mentioned previously, most of these medias are very porous. So if any water molecules or grease or particulates get trapped in the media, it will prevent the media from working effectively. So, and that could reduce its life. So we want to take a look at that. Next question. How do I find out what gases that should be removed? So the best way for that, if you're not sure, we would recommend, if possible, to take air samples, whether that's using Tedlar bags or some type of sumo canisters. So you can test the air, send it off to a laboratory, and they'll tell you exactly what's in the airstream and the concentration levels. And from there, you can determine what will be the best media to use to remove those different gases. So, and if you're not able to do that, then maybe if you're near a plant that's producing gases, you should be able to receive a copy of their MSDS and see what chemicals they're using. And then from there, we can talk with our in-house expert to determine, that gas, what's the best media to remove those different gases. So it's a few different methods for determining, different types of gases that we typically would start off with, but really we like to take that air sample to determine that. And then last question here from the submitted questions: how can I tell when I need to replace my media? So you may hear some people say, well, you can use your nose when it's time to change out the media, which that's more of a reactive approach, which is not necessarily the greatest. So in those cases, you want to have a couple of different methods. You can take a sample and send it back to, a company that has a laboratory that can test media, and send a report back to let you know, all right, well, here's the media life. That could take some time for that. You have to take the sample, ship it, wait for the results, and then get the email. Or there's a few different devices that you can provide that we have. It's a manual device, more like a rod, where we're measuring that, or we're monitoring that working zone or that active transfer zone, so we can determine. And we just recommend pulling that rod monthly to determine how that media is being consumed. But most importantly, I think the best method would be using, we have an electronic version of that called our lifeguard that we can use to monitor media life. So that way, you know exactly when it's time to change out the media, and it sends alerts and alarms to the end users, can be monitored by the building maintenance and also consultants as well. Okay. And now we're getting to some live questions. We do have one from, it looks like that is from LC Reyes. So it says, what is the color change of the safety zorb when there is a leak of gas? And if there's not a leak, what is the media lifetime? Great question, LC. I hope I pronounced your name right. So there is no color change for safety zorb. So it is white in color. And when that media is used up, it stays the same color. So really the only way for that, if you have for example, a lot of the safety sorbs used in emergency gas scrubbers, so it's targeted to remove the entire contents of in this example, chlorine gas. So it's targeted to remove the entire contents, say, of a 1-ton overfilled cylinder of chlorine gas. So when that cylinder releases, you have to replace all that media we know is spent. Now, say, for example, only 100 pounds or so is released. And so not all the media is used up. So in that case, we would recommend, if you had that type of a situation, take some samples of the media after the event and send that into our lab to be tested. And then from there, we will determine, the different ports or where the media was taken from, what that media life is in each port. So then from there, you can just replace only the media that was spent, and then the rest of the media will be fine. So, but that was a great question. Let's see, any other questions? Don't see any. We've got a question from, hello from Hassan. Hello to you as well, sir. Let's see, any other questions? Any live questions? All right, let's see, none yet. Again, I think I went to this here just to kind of give everyone an idea what the medias look like. Again, whole host and family of different medias and blends. So if there's a gas out there, you come to us, we can definitely have a solution to remove that gas. So let's see, any other questions? No other questions? Oh, all right. Well, if there are no other questions, we will go ahead and end the presentation. And again, if anyone has any other questions, please feel free to direct them to info@PureAir Filtration, and we will